Hello guys, so welcome back to our VHDL lessons. In this lesson, we're gonna explore another example number 2 for function or boolean function implementation using muxes. So as you see in the screen, this is the design that we explored in the lecture. Okay, we did this design using two methods. Once using 8x1 multiplexer, and the other one was using a 4x1 mux. I'm gonna leave the 4x1 mux as a homework for you, and I'm gonna do the 8x1 mux to you now. Okay, so this was basically the design as we learned in the lecture. You know, you have 8x1 mux, so you have three inputs basically for the function a, b, c, d. Will be assigned to the selection bits here, and the fourth, which is d in that case, will be assigned or basically, you know, the 8 inputs of the mux will be a function of that d. Okay, and we did divide the, you know, the big truth table with 16 combinations into 8 divisions, we can say, because we have 8 inputs. And we found that, you know, for example, input 0, input 1, and input 5 equal to d, input 2 equal to d complement, input 3 and 4 equal to 0, and the input 6 and 7 equal to 1. Okay, that was basically the design. Okay, so I have, you know, an 8x1 multiplexer, so I make out of it a package. It's easy to do. And here is, you know, the entity of that design. Basically, the entity is, you know, let's draw it very quick here. So our entity should be something like this. You know, this is a design that has 4 inputs: A, B, C, and D, and the output should be F. And basically, this is a design that will be inside that box. And this square is basically our entity, which defines, you know, the inputs and the outputs of the design. So basically, the inputs is A, B, C, D. The output is just F. And all of them are standard logic. Okay. We need some signals inside. So basically, my 8x1 mux has 2 inputs. So one input is called S, which this is 5, not S. So S is 3 bits, 3-bit input, or 3 bits. And another input, which is basically called the I. And I is basically 8 bits. Okay. Okay. So that's what I have done here. So I defined 2 signals, a signal called I, 8 bits, 7 down to 0, or 8 bits, and a signal called S, which is basically the selection, which is 3 bits, 2 down to 0. So I of 0 is basically I of 0, I of 1, and I of 5 equal to D, like what we see here. I of 2 is not D, I 3 and 4 is 0, I 6 and 7 is 1. And S is basically the concatenation of ABC. And you know, the order is very important. A here is the second bit, third bit, I'm sorry, bit number 2. B is bit number 1. C is bit number 0, or the least significant bit. And here is the concatenation. You cannot say C. This is the only correct way. You cannot say it in any other way. You cannot say C, for example, concatenated with B, concatenated with A, or B concatenated with, you know, B and C. B, A, and C. So this is the only correct way. A must be the most significant bit, C must be the least significant bit, and B is in between. This is your choice in the design here, so you must conform with it in the coding, because this coding is basically representing this design. Can we make A, yeah, if you change this design and make A S0, that's fine. But you should again do that here. We'll change it, it changes that in the coding as well. So the coding must be a replica of what's inside, the design, your design. Then we instantiate an instance of the mux from the mux 8x1 package and connect I to its input, S to its selection, and basically F our output to its output. And that's it. It's really easy. Let's simulate that. Start simulation. And I'm gonna open work here. We need mux. That's going down. Yeah, the name is a little bit weird, but I just put so if we go back to the original question here is the minimum term that represent F 1, 3, 4, 11, 12, 13, 14, 15. That's basically the name here 1, 3, 4, 11, 12, 13, 14, 15. Okay. Okay, here is the inputs and the outputs. We need just 16 combinations, really easy. Oops. And here, let's make it 20, for example, that's fine. And we can just simulate. Let's check, zoom out. And go back a little bit, yes. So, to know if you are correct or wrong, just check the truth table against your output here. So if here, let's make F with another color, yellow, for example. And okay, so we have 0, 1, 0, 1, then 0, 1 again, 0, 1 again, then 1, 0, 1, 0, then 4 zeros, 1, 2, 3, 4, that's nice. Then 0, 1, 0, 1, then 4 ones, 1, 2, 3, 4. The rest is because I continue with 20 cycles. If I stop at 16, this will be the last bit. But I continued, so the simulator just use the last bits or the last values for A, B, C, D, and F. Okay, that's basically the design, guys. As you see here, it's correct. Okay, and now it's your turn to implement the same design, but using a 4x1 mux. Okay. Thank you very much for watching this video and see you in the next lesson. Bye-bye.